This meeting is a direct result of a conversation that Alex and I had back in January. I think you saw a press release for a conference that we were doing at the West Tech conference in Chicago. And every item on the press release that we had in there, he said, this represents knowledge gaps that we have in Region 1 about chemical grouting. We need to solve that. So we got together, we talked about how we might close some of those gaps, and we elected to do this as a interactive presentation, a webinar-based presentation, and I've called in a couple partners to make that happen. One's a technology partner, one is a contracting partner. I'll introduce you to those folks in a moment. So, what is so great about New England? Well, in one word, everything. In this 6-state region, you're the first one to get fall colors, and certainly have the Atlantic Ocean as a hallmark for your region. You're also a region of extremes. Temperature extremes, population density, soil types. All these things come into play here. Cultural diversity, history, and because you are a rather older portion of this country called America, we have what we call some infrastructure decay. That is the reason, driven by infiltration, for the purpose of this webinar, and that is to discuss the role of chemical grout for the restoration and revitalization of aging infrastructure, as well as the sustainability of collection systems in the New England region. I hope everybody's good with this purpose. You're going to have questions, and I encourage them. In fact, we're going to try and make a 35-minute presentation, leaving 20 minutes on the backside for true interactive question and answer, and that happens through the transom. That happens through you submitting questions on the question box there on the right bottom right-hand side of that collapsible dialog box. So that's how we make it interactive. That's how we make it relevant to you. I have the pleasure of introducing subject matter experts for the day. On the left-hand side, you see Mark Anctil. He's the president of Logiball. In fact, he's not too far from Region 1. He's from Quebec City, and he's the president of Logiball. And Mark and I, and Mark and Avanti, have been partnering together for a long time. And education is one way that we often go to market. Daniel McGill is someone you'll come to know and recognize if you don't already. Daniel's the president of Avanti. His father founded the company. Daniel's been buying the company for a sequence of years now. And Daniel is our leader and very passionate about chemical grout, as well as other technologies in the trenchless industry. John Regan is, and Will Markley are both from Heitkamp Incorporated. John has a BS in environmental engineering. He's worked with chemical grouting for 20 years and has experience in all trenchless rehabilitations and their interaction with chemical grout. Will Markley has had 20 years of experience in trenchless industry. 17 of those has been as a project manager for in situ form technologies, which you'll recognize as probably the lead vendor for CIPP and folded form and other technologies associated with lining. Currently, he's the project manager for Heitkamp and is a trainer for NASCO's CIPP inspector program. There is, as I understand it from talking to Alex, infiltration is a major issue in New England. It is in all parts of the country, but especially New England because of the conditions up there. And I'm now going to ask Mark Anctil to take on the first presentation, and I will make you presenter, Mark, right now. And if you'll acknowledge, I appreciate that.
All right. If I can get this rolling. Okay, everybody can hear me. Thank you for attending. Before we understand infiltration, we basically need to understand what we have or what we've been given as a system. So if we go back to the last 40 to 100 years, we've got lots of pipe in the ground, and that means lots of joints. We're seeing a gentleman right here that is basically pouring hot tar over a joint on clay pipe. Clay pipe is one of the best pipes in the world, but if our joints basically fail, then our system fails. We have, everybody's seen this kind of chart before, where we have a rain-derived infiltration and inflow after a storm event. We hit a peak, and a few days or hours after that, we'll basically get our flows at infiltration and going down back to normal, whatever normal is. This is a famous EPA drawing from the 90s. This is basically what we have in the ground. We've modified this drawing or updated it to this year, and there are a lot of pipes in the ground, a lot of different trenches. This is only pipes. There's utilities also that we're not seeing. All these are basically pathways or highways for any trench water to travel and migrate in between each other. We have our house foundation drains. We have our basically gutters coming down over here, storm sewers, laterals, mainline sewers, and storm sewers. So it's a big underground utility spaghetti. Here's another close-up view. Typically, our storm sewers are not as deep as our sanitary sewers, but they will cross paths in a way and basically make it easier for any trench water or water escaping from the storm sewers to get into the sewer system and overcharge our systems. Here's another view of the whole thing. We have our catch basins, or catchments, foundation drains, storm sewer, sanitary, basically whatever is underneath this. If I can get this down here. Okay. Green represents infiltration or groundwater. Okay. Our sewers are basically near or above the groundwater table. But as rain events happen, basically the ground is being surcharged with water. Anything that's within the storm sewer system that's not completely watertight will basically fill up the ground, and infiltration occurs in our storm, from our storm into our sewer system. So if we have this rain event and it surcharges everything, then we get exfiltration. That means sanitary sewer water going out into the soil. Okay, not good either. As this happens, basically we have a water going out and then water coming back in after the surcharge. So exfiltration is sewer water going out into the soil. Okay, this is what we see here with the pink. On the green, we'd have our normal or below grade groundwater, and this is raises the ground level. Infiltration occurs. So we have this movement of infiltration, exfiltration back and forth. Here's what we mean by infiltration, that water from the ground coming in. As this happens, back and forth, left unattended, we're going to get areas, or first SSOs, maybe even CSOs, depending on our system. And the more and more left unattended, what happens is we're undermining this sewer system. The joints are pathways for water and the fines to come into this and create areas where what used to be just a simple infiltration problem becomes more of a structural issue. Right? Here you see whatever's being non-supported over time. That's creating the problem to complete failure of the system. So what's our moral obligation to future generations? What do we need to do here? Right? If left unattended, things like this can happen, and they have happened. Right? Our structures are sound, but the joints were leaking, allowing groundwater and fines to come into the system. As this happens, we surcharge our system, put them back where they belong, but untreated. Not good. Increased cost to treat at the wastewater treatment plant. More water coming in dilutes the chemicals we use in treating this water. Reduced life cycle of the collection system. This amount of water coming in, pump stations will be running 24 hours a day. So there's the cost of the pump station and running the pump stations and other infrastructure. And of course, basement backups. Taxpayers don't enjoy this kind of scene here. So with this, what do we need to do? Well, proactive maintenance beats reactive repair every time. Daniel?
Okay, thanks. All right, so we'll spend a couple of minutes talking about the sources of infiltration and the system as a whole. You can see on the diagram here we've identified 4 points of entry. You've got manholes, mainline joints, lateral connections, and a few feet up the lateral. They've grouted as much as 30 feet up the lateral in one shot. But what's significant about this diagram is that if you focus on stopping the infiltration, say just at the mainline joint, where does the groundwater go? It's going to follow the path of least resistance and come in at a different point. Maybe it's at the lateral connection or maybe it's at the manhole. So you really have to focus on sealing the whole system in order to see a reduction of flows at the treatment plant. This next slide, the process of sewer failure, is probably my favorite slide in the whole presentation. If you look at stage 1, the initial defect, you see that groundwater is coming into that joint, and if they grouted it now, it would last for decades. And on the top right, the pipe is structurally sound, everything is good, it's just infiltration. In stage 2, if they haven't done any proactive maintenance or preventative maintenance, then you see the void outside the mainline joint getting bigger as the fines come into the pipe, and you're starting to see deformation of the line. And on the far right, you see some structural problems beginning. They could potentially grout that now as well, but if they don't do anything, stage 3, you have failure of the pipe, and now you can't grout it. You have definitely have a structural problem, and you have to have a structural solution, which is going to be more expensive and more of an emergency repair than proactive maintenance. So what are the rehab technologies out there? You see dig and replace, fold and form, sectional lighting, pipe bursting, slip lining, CIPP, and chemical grouting. All the ones that are white in color, what do they have in common if you look at each one of those? They're all structural rehab technologies. If you have a structural problem, then you need a structural solution, and that's great. The problem is a lot of engineers spec structural solutions when all they're really trying to do is stop the infiltration. And that's where chemical grouting comes in. It's the only solution that's specifically designed to stop infiltration. So let's take a look at how grouts work and define it. Chemical grout is a liquid resin that turns into an impermeable solid in a predictable time frame. It's used to stop leaks in above-grade structures, stop infiltration in below-grade structures, stabilize soils, control groundwater, and seal the annulus between the hose pipe and the liner. In the municipal market, there are essentially 2 families of chemical grouts. We've broken it down to the acrylic family and the urethane family. Acrylics are further divided to acrylamide, acrylic, or acrylate grouts, acrylamide being probably 90% of what's used out there, and polyurethanes are broken down into, they can cure as a gel or an expansive foam, and that foam can either be flexible or it can be rigid. It's flexible if you're in a moving concrete structure, or rigid if you're filling voids underground. So why is it that acrylics and acrylamide are the primary chemical grout used in the municipal market? If you look at the photo in the top right, you'll see that they're pouring 2 liquids together. They're both the same viscosity as water, and they put a dye in both cups. They put a blue dye in the left cup and a yellow dye in the right cup. And when they pour them together, the gel turns green. So it's a way that the contractor and an inspector can track where's the grout going. But if you were to see this live, you would be able to tell that it's just like water. Without the dye, it's the same viscosity as water, same color, you can't tell the difference. So it's the thinnest product on the market. It can go anywhere water goes. There's no suspended solids. Like if you're pumping cement underground, that cement is only going to go through the soil or through a crack fissure as far as that particle size will allow it to go. Well, here there are no particles, no suspended solids, so it can go anywhere water goes. Field adjustable cure times. the contractor on the grout truck can make this liquid turn into a solid in 5 seconds, all the way up to 10 hours, depending on how far they want it to travel in the soil. And in municipal applications, it's usually not extended that long. They usually don't need it to be that long of a cure time, but they can control it if they need to. They can also control the gel strength if their CCTV shows that they've got a lot of infiltration in this particular segment of the line. They can pump a stronger grout to compensate for the dilution that they know they're going to get when they grout that section. Soap and water cleanup, it's not activated by moisture. Urethanes, when you pump a urethane, you have to pump acetone through the system beforehand to remove moisture from the hoses or humidity from the hoses. Otherwise, that humidity or moisture can activate the grout. So with acrylics, they don't have to worry about that. Therefore, there's no need for solvents, and there's a successful track record. They started using acrylamide grout in the U.S. Halliburton started using it in the 60s for soil stabilization. In the 70s, they started using it to seal mainline joints. And that leads me to the next slide. Talks about longevity. The U.S. Department of Energy in 1985 started a 20-year study where they studied 7 different types of grouts, and they were trying to determine what did they want to use to encapsulate some radioactive waste in Oak Ridge, Tennessee. And they chose the same grout that they're using in the municipal mainline and lateral sewers, which is acrylamide grout. They gave it a 362-year half-life in the soil. And that was very significant because people said, well, this grout only lasts a day or so, because they would let it sit on their desk or put it out in the parking lot. And that's right. If it's not underground, it'll shrink and shrivel up. But when it's in a moist environment, even a humid environment, we sell grout to tunnel projects in Egypt, where it's very arid, but there's enough humidity in the soil to keep it happy. So when you're using it in a municipal application, there's moisture outside the pipe in the groundwater, and there's humidity and moisture inside the pipe in the sewage, so it keeps the grout happy and can last a long, long time. With that, I will pass it over to John Heitkamp.
Thanks, Daniel. Good afternoon. Just wanted to talk briefly about the actual application of chemical grout into our sewer joints, into our lateral connections. I guess the first part would be the proper preparation of your pipelines and your laterals before you can actually go in and chemical grout. And this could involve doing a preparatory TV inspection to identify which joints might be leaking. Could also involve root cutting, pipeline cleaning to remove the debris. All of those should be done ahead of putting your packer in to actually start your chemical grout injections. Some of the components that are out there you see on the screen here. You have your packer that's down in the pipeline that's actually going to be injecting the grout. It's leading into the truck there, your grout truck, which has your chemical tanks, your pumps, your CCTV operator compartment, etc. Your chemical grout, which you would typically store inside the truck, and it gets mixed in the truck there. You'll also notice, too, the minimal traffic impact that this setup would have on your typical municipal street. Once the pipeline, the packer is inserted into the pipeline, you're going to use your camera to guide it onto the joints. You see this infiltrating joint here. You're going to pull the packer onto the joint, and at that time the end elements are going to inflate around and create a void around the joint. At this time, once the void is created and it's sealed up, you're going to pump your grout in through the packer, and it's going to go outside into the surrounding soil and form that gel that's going to stop the infiltration. And it's a common myth that it's only sealing just that area of the joint, but in actuality, it's actually surrounding that soil and creating a grout collar around the pipe that's going to form that barrier to infiltration. This is a little animation about mainline sewer grinding. You can see your infiltrating joint here. Your camera is going to guide the packer onto the joint. The end elements are inflated, create the void. The grout is injected out into the surrounding soil. And this is done sometimes at multiple stages until refusal. Once the grout is cured, the elements of the packer are deflated. It's pulled away, and you examine the joint to see if there's any infiltration left. Another common fallacy is that CIPP lining is going to stop infiltration, but it doesn't. It just moves it around, really. You can see here the liner coming through. it's going to stop the infiltration until they reinstate that lateral connection, and it's just deferring all the infiltration that was originally coming in through the cracks in the joints up into that lateral, and it's just pouring into the pipe at the same rate. With lateral grouting, you can actually stop that infiltration permanently. So it's kind of a similar process where you're pumping the grout out into the surrounding soil, creating a collar around it. So here's a little animation about lateral grouting. It is typically done in 4 to 30-foot increments up the lateral connection, depending on the municipality and the configuration of the laterals. See your liner in and your sealed lateral connection. The camera is going to guide it in. The packer is rotated so that the lateral sock will line up with the lateral connection. The elements are inflated on the outside. The lateral sock is extended up the lateral from 4 to 30 feet. The grout is injected. It creates your grout collar, seals around the leaking joints and defects. Also between the hose pipe and the CIPP liner, it will seal that off as well. And then everything is retracted, and it would move on to the next service. There's an example here of a grout donut that was dug up in the ground. It's been in the ground for about 25 years. You can see the longevity that the grout has, and it's still all attached to the pipe. This joint is watertight, and it's been in the ground for 25 years. So there is some longevity to grouting, and it's going to be an effective solution to stopping infiltration. At this point, I'll turn it over to Mark Enkel.
Thanks, John. In order to be successful, we do, of course, need standards and best practices, okay? There's got to be a minimum repeatable performance standards for the delivery system, the chemicals, the tools, in order to get success. And these best practices have been developed by people in the industry who have lots of experience, technologies, and know-how. One of these documents is the Suggested Standard Specification for Pressure Testing by NASCO. This is a document that's been put together by engineers, contractors, technical providers, and been peer-reviewed. So this is a very important document, and I encourage you to have a look at this. Other standards that exist that came into, I think, early 2000s, there are ASTM standard practices, okay, to seal mainline joints, to seal service connections, and to seal manholes. And again, we have the NASCO and ICGA suggested standard specifications. They're documents that are there to make sure that the process is done to the best of your abilities. So talking about process, one thing we need to do, of course, and John said it earlier, is clean the system, okay? We also need to inspect the system. What do we have? Before we want to fight it, we have to know what we have, okay? Assess the condition of what we're finding out, okay? And then, according to this, prioritize. Where am I going to get the biggest bang for my buck? Basically, that's what it comes down to, okay? And then, according to all these information, which rehab technology is most appropriate? If we have infiltration without any structural issues, well, of course, chemical grouting is number one. If not, you have structural issues, well, relining and in combination with grouting can be used. So our grouting process, or test and seal process, because this is a process and it is a test and seal, okay? So our first is testing the joints, service connections, seal the ones that are not passing these tests, okay? Seal till refusal, pump the amount of grout that's required, and of course, validate what you've just done by a post-test. Daniel, back to you.
All right, I'll spend just kind of finalize that whole point of sealing the system. And Mark, you brought up a good point, grouting in conjunction with lining, and I don't have a graphic for it, but sometimes contractors, maybe in the Q&A, John and Will can talk about this, but sometimes they'll even grout mainline joints before lining, just so that they don't, so that that infiltration doesn't pose a problem with the liner in terms of resin washout or a bubble. And when it comes to manholes and sealing that part of the system, There are several different ways you can do it. You can take oakum and dunk it into an expansive resin and stuff it into a joint, and it'll create a new gasket. Or you can do crack injection, where you inject a resin into the concrete wall itself, and as it hits moisture, it expands and cures into a flexible foam, so that that new gasket will move as the concrete swells and shrinks with temperature. So you've got a dynamic crack, you need a dynamic solution there. Here you see an image of curtain grouting, where they drill a hole straight through the structure and they pump the same grout that they use in the municipal or in the mainline or lateral grouting. They pump it into the soil outside the structure, whether it's a manhole or lift station or a wet well, it doesn't matter. And they create an impermeable curtain around that structure. Especially if you've got a brick manhole, you're not going to want to chase the water from crack to crack or in between all the bricks. So here, they encapsulate the whole manhole rather than chase the water around. And in the very last slide here, you'll see an image of what we would consider is you've addressed all of the infiltration in the system. So the manhole is sealed, the mainline joints are sealed, the lateral connection, as well as up the lateral, depending on whatever the local standard is of how far you need to go up the lateral. Will, I'll pass the next slide on to you.
Okay, thank you, Daniel, and good afternoon, everyone. Thanks for attending. Over the past 40 years or so in the chemical grouting industry, the science of the available materials and the equipment and the art of their application has progressed and improved significantly to the point where we now have proven standards and procedures in place. The industry has indeed come a long way. Chemical grouting was the first available technology for improving the efficiency and longevity of our underground infrastructure. Where the structural rehabilitation methods that we mentioned earlier are not required, chemical grouting is the most cost-effective technology for reducing infiltration in all of the components of your system, be it the manholes, the laterals, or the main lines, as we've shown. And therefore should be the first choice for rehabilitation. I'm kind of the relative newcomer to this group, having only been directly involved with chemical grouting for about the past 3 years. And as Don mentioned earlier, prior to that, I spent about 17 years with Insituform working on structural rehabilitation. In that time, I spent a lot of owners' money installing structural rehab, where the sole intention of the client was actually just the reduction of infiltration. In my 3 years being involved with the chemical grouting industry, I've certainly become convinced that it should be the first option considered. And of course, those of us here are all representative from the industry, but it has been evaluated and endorsed through other educational and professionals as well. And Don, I'll turn it back to you.
Well, I think this is a profound statement that Dr. Vippu has made from the University of Houston. To date, the only proven method of stopping infiltration is the application of chemical grout. Based on its cost effectiveness, durability, and method of leak repair for sewer pipe joints, manholes, and laterals, chemical grouting has proven to be the least expensive remediation alternative for stopping leaks and infiltration. Daniel, help me understand when this statement was made by Dr. Vippu. You have a relationship with him. Do you know when that statement was made, when that paper was written?
I don't. I'm not exactly sure.
Okay.
I think that he came out with a white paper around 2005, so that's my guess. It was around.
Yeah, I think it was timed with that. You're right. All right, thank you for that. Look, I want to thank you, presenters, for trying to keep this thing honed into a 35-minute presentation so we can then be interactive with some real Q&A. And while you're building your questions in advance and typing them in, I will kind of review what we talked about here real fast. And what Mark first showed us was a look at the sewer trench. The sewer trench actually creates a French drain effect, complicating things and intensifying this infiltration problem centered around the sanitary sewer, typically located well below the storm sewer. Beyond that, we talked a bit about consequences of no action. Beyond that, we talked about the 4 points of infiltration and the 3 stages of sewer failure. And then we talked about all the other technologies that can work for us. And and we're grateful that they all exist, but they're all structural repairs. There's only one non-structural repair, and that's chemical grout, and it is the only one designed to stop infiltration. If the infiltration is the battleground, chemical grout is the weapon. We talked about why which municipal grouts are most appropriate, such as from the acrylic family. We talked about longevity. We talked about the process of sealing main lines and sealing laterals. And we talked a bit about some standards that exist. That from NASCO specifically, and the process involved in getting that done, and the confidence that that brings to bear for the engineering community, for the municipality, and for the contracting community. They have one set of guidelines, and it's adhered to. We talked about manholes, and then certainly we just ended with Will's presentation, coming from the contractor point of view of a lining organization. We have a pretty clear statement and a compelling reason to consider chemical grout. I am going to ask that these questions get sent in comparatively. All right, now they're coming in. And pardon me while I try to do both here, present and to direct these questions. How would a work plan be presented to a client to work? We're trying to see how we can assess both a plan to grout and how effective it is. So let me think about that. Let me restate that again and direct it. How would a work plan be presented to a client prior to work? And we're trying to see how we can assess both the plan to grout and how effective it is. I'd like for John to take that on, if you could.
Well, as far as determining the effectiveness of chemical grout, it's typical on many of the projects we've done where they've actually gone in at nighttime and taking infiltration weir readings in the individual pipelines. Then they come in and they will do the chemical grout application. And then after that is done, they'll come back and do weir readings again. So you're seeing the actual reduction in flow per line section, which you can compare to, the cost of actually grouting that pipe. So that would be one way to kind of prove the effectiveness of the chemical grout in that one particular line section over a course of a project. As far as the plan goes, I'm not exactly sure what they meant by that, but I mean it's typical that sewer pipes or a system will be televised ahead of the grouting coming in. Determinations will be made about the type of rehab that's going to be most effective based on the results of the TV inspection, and then a work plan will be developed from there. I think that was what was kind of alluded to.
I think you're right. I've got another question here that I knew was going to come up at some point. We're looking for cost comparisons, guys. What's it cost? What are the comparisons with other technologies? For instance, a rule of thumb that I've been operating on is if you spend $1 in grouting, you can spend $3 to $4 in lining. You can spend $10 to replace, to rip and replace. I
think that's
really
a fair comparison.
Do you think, can you be any more specific? Like Daniel or Mark, you and I have studied this for a while. We think that we know a price per foot for grouting, a price per foot for lining. Can you all go into detail on that?
Yeah, this is Mark. This is going to depend. I mean, if you're going to get a contractor to go out and just do a couple of joints or a couple of services, the price may be radically higher. But if you have a test and seal program where you're going to test all the individual joints and seal the leaking ones, then the cost is probably going to be down to about a third of what lining and maybe a tenth of what replacement costs. Now, if you're doing laterals further up the line, if you're going 30 feet, well, you're going to have to inspect the lateral and clean it. But if you're doing the first 4 or 6 feet, typically lateral inspection or cleaning may not be required, of course, depending on the conditions and what's going to be seen with the pan and tilt camera.
And I don't have a whole lot to add to that. As Mark said, it depends on what the spec is and where in the country you are and what's required up there. The chemical itself is usually the least expensive part of the equation when you factor in the cleaning and inspection and everything else. And you want to make sure that your spec doesn't just say go in and grout the joints that are leaking, because they really need to air test every joint. If it's leaking, then great, you know it's leaking, grout it. But if it's not leaking, you should still do an air test, because once you seal the joint next to it, the groundwater is going to flow to that joint, and you need to make sure that it's not leaking before you pass it up. And I also would say if you do a trial section, we're going to do this 100 feet or this 500 feet or whatever, that you also need to, if you're going to measure flows, you got to address all the leaks again, because if you do just the main line, it's going to start coming in at the lateral, and you're going to say, wow, grouting didn't reduce our flows, it must not be a good technology. But when you watch the video after they grout a joint that's really gushing water, you'll see it stops that water right away. And if you go back months later, it still is stopped, even though your flows might not have been reduced because you haven't addressed the whole system yet.
Daniel, you touched on something here that a question came in at the same time that you actually mentioned that. And that is, when the work is done, what percentage of the cost is the grout itself? Because if you were to hit a very permeable zone, or even have the grout infiltrate into the storm sewer pipe in close proximity, would the loss of the grout increase the price up dramatically? Do you follow
Absolutely.
that?
Yeah, sure. I mean, the grout still costs money, so if the more you grout, the more it's going to cost you. Question of how much of a percentage, I'd have to defer to the contractor, I guess. I can tell you grout is typically, let's say, $6 to $9 a gallon, and you might even say $6 to $9 per linear foot if you're going to try to compare it to lining, say. And you guys know what the cost of lining is in the Northeast better than I do. I would guess somewhere around $30 a linear foot. But Will and John, do you guys have an idea of what the cost of grout is percentage-wise on the whole project?
It's in reality, it's a minimal percentage of the actual work itself. Up here in the Northeast, with prevailing rates, you'll typically find that the labor is actually the largest component of the application, and the grout becomes a minimal point, probably 15 to 20%, if that at most. But really, the labor is really the biggest cost. And as compared to a cured-in-place lining project, you need 2 guys to do a chemical grout application, whereas you would have 6 or 7 guys on a lining crew. So, there is a savings in the labor, but as a percentage, the labor is definitely the biggest part.
That's a nice transition to this next question. How is this type of work guaranteed? And I think Will or John, you are probably, excuse me, best able to answer that.
Yeah, typically, at least here in the Northeast, most of the projects that we're a part of have what they call a guaranteed retest, whereas a year or 2 years would go by, and you are brought back in to retest joints that you had sealed previously. And it's usually a percentage of the total project, 15, 25, 50% sometimes, but they'll have you actually come in after a year's time or more and retest the joints to prove that they are still sealed.
There's also this is Mark, there's also an option that's defined in the NASCO specification within a given period of time after the completion of the work, that CCTV inspection during high groundwater table could also be used as a warranty item. So it's either one or the other.
CCTV or pressure test.
That's correct, a portion of the work.
And when you guys air test, is it just at what pressure do you, if it's a year later, what pressure do you use to air test?
It varies from spec to spec, but typically, always as a rule of thumb, usually like a half a pound or half a PSI per foot of groundwater over the pipe or the depth of the pipe.
Dan, here's another question I think is best responded by you. Are there any incompatibles with other material, as in hydrogen sulfide? I know that the acrylics are very chemically resistant, but I'll let you respond to that, if you would, please.
They are. I don't have a chart in front of me, but we can certainly provide a chart that talks about its chemical resistance. And it's a really durable material. That's why it was chosen to encapsulate radioactive waste. And it's been used in the sewer for a long, long time. And it doesn't, whatever's in the sewer, if it's H2S gas, doesn't break it down. But also keep in mind that what's left, the day after you grout, is on the outside of the sewer. So it's really what's more important is what's in the groundwater. Are there contaminants in the groundwater that can hurt whatever your rehab is? It can hurt the grout. And we've seen grout used in some really crazy places to encapsulate a structure that had a lot of contaminated groundwater, and it does very well.
Hey, Will, with your experience in lining, you could probably best answer this. Is this process also faster than other rehabilitation processes?
It's a bit of a tricky question. To line a main line is fairly fast. Say a 300-foot shot, you may do it in about the same amount of time. But with the lining, you would only want to do it if you need a structural repair, for one. And two, you're really just kind of minimizing the infiltration that's coming in those mainline joints. You're really moving that infiltration to your laterals or to your manholes. So if you kind of looked at your whole system, doing structural rehab on laterals, manholes, and a mainline, it would take much, much longer and much more money than grouting all of those components. There again, if you're looking at reducing infiltration.
I'm thinking about some other webinars that we've done focused on certain cities and contractors and engineers who kind of collaborated on this, and the kind of value that they have created for the municipality. I'm thinking of Granite City. I'm thinking of the job up in Illinois that that was accomplished. I'm thinking of the city of, Miami-Dade County. The kind of, statements like, for every dollar they invested in their I&I program, they got a $2.50 return of a team that's cost avoidance. They did not have to upgrade their plant, did not have to line their system. So they avoided $2.50 for every dollar they spent in chemical grout, and I thought that was a very profound economic reasons and a really solid business reason to view chemical grout as a lead technology, not a secondary technology. Here's a question that I'm not sure who should go to just yet. Could this technology be used for sealing a brick pipe that is almost fully porous, like an underdrain was intentionally designed into the system? Do you guys know what we mean by underdrain, John, by chance?
Yes.
Could you respond to that question?
There could be a couple different ways that you could actually grout that brick sewer. If it's large enough for man entry, it could be sealed quite like a manhole would be internally. There's also other ways to seal it by using ground penetration and actually drilling down from the surface and pumping grout into the soil around the pipe without actually getting into the pipe itself. You can't really obviously do it by traditional means that you would do normal joint sealing, but those are two methods that you would be able to maybe possibly seal that brick sewer with.
So probe grouting is the technique you're talking about from the top, from the surface
Correct.
down.
Correct.
Do you have confidence in probe grouting touching all the right places and sealing that in its entirety?
Yeah.
That was a good straight answer.
Because you can verify it on the inside with a camera or a person, right? You can see where the
Correct.
the top. Yeah.
Correct.
There's an animation on our website and on YouTube for a subway system, and we created that after the city of Toronto started sealing their subway system with chemical grout, and they just drill holes from the inside and create that curtain. So they don't go from the surface; they go from the inside. But yeah, you could do it either way.
Alex, I see you trying to type as quickly as I try to respond to these questions, and we're both multitasking. Ah, look at him laugh. Okay, here's one. Is that similar to for all large diameter pipes? For instance, we talked about that brick, large diameter brick pipe. We just did a huge job in Granite City, which all large diameter pipe, up to 109 inches, I think it was. And Logiball built a unique packer, customized a packer for them. And what I recall from that job site more than anything else is they were able to do 3 times more system by grouting versus lining. They affected 3 times more of sanitary sewers than they would have been able to if they were to line that system. And we know for a fact, they went back a year later, and they're sitting in the American Bottoms. And the American Bottoms is right there where the Mississippi and the Missouri rivers come together right outside of St. Louis. And that place floods every single spring. They've been through a full year cycle now. And there's no new sinkholes. And beforehand, it looked like a war zone. The downtown area was just a horrendous problem. But they did the large diameter sanitary sewers, and they did 3 times more territory as opposed to lining, and that was profound to me. I think I got some more questions in. Alex, you're not slowing down on me, are you? I think I haven't missed any by design here, folks. I'm trying to look at everyone and be responsive and make this thing as relevant for each of you. But if, in fact, there are questions that I haven't responded to, we are more than happy to electronically communicate back to you and respond. I'm going to the very top of this list again to make sure that I haven't missed anything. And I'm trying to be sensitive to time. I know I've got a couple minutes left, and that's about all. We got to the guarantee part. Look, I think we've answered all of them from your submittals, Alex. Thank you for that. And I think what I'd like to do is start to summarize this thing, because I'd like to stay true to 1 hour. And when we ask for 1 hour of your time, we ask for an hour of attentiveness, and not to go an hour and 15 minutes. That's not respectful. So these are promise documents that I think would be meaningful to you. And this NASCO specification will send you a link to this, and you may download it, read it, consume it, understand it. Here's a white paper that's centered around chemical grout for wastewater systems. It is about 2 years old, but it's as relevant today as it was written a couple years ago. And these are items that are takeaways that kind of summarize some of the things we talked about. And I hope that you found this 1 hour session meaningful. And what I'd like to do now is ask for each one of our presenters to exit with some thought process about today, how much you enjoy this. Mark, please.
Thanks, Dan.
There, if you will.
Just a few words. We're talking about joint sealing laterals, but this is really a systematic approach. I mean, you just can't just go in and seal just the joints or just the laterals. The water will migrate to the lowest point or next point of entry. So it's important to view this as a system approach. Thanks.
And Daniel?
Thanks for the opportunity to have this type of meeting. As Don mentioned earlier, we're all about education. So anytime questions come up, let us know how we can help. Our website is a wealth of information, both with case studies and animations. And we do at least usually one or two grout schools every year, where some contractors come, some inspectors come, some engineers come to get some hands-on experience and to do some grouting. So those are options as well.
Education is the way forward, right?
Yes, sir.
It is for Avanti. John, please.
Yeah, I just wanted to thank everybody for their time this afternoon. I kind of want to echo what Mark had to say in his closing remarks, and that the approach to grouting, it has to be a systematic approach. I've seen many a project where they decide that we're just going to grout this one pipe in the laterals in that one pipe, and as soon as they do, it starts leaking in the pipe that's upstream or downstream of it because it wasn't addressed. So systematic approach to grouting is the most important way to make sure that you're getting the results that you're looking for.
A great takeaway, John. Thank you. Will?
Yeah, again, thank everybody for attending. I think everybody's put it fairly well. The whole system approach is the way to go, and I hope we made it clear that you can certainly use grouting in conjunction with structural rehab. If you have the need for some structural rehab in your system, the grouting is a very good complement to the other areas to look at the whole system.
I will close with this one thought, and that is, let's look at this 1 hour time investment that you guys have put together to hear this presentation. Let's let it be maybe the first initial conversation of a series of conversations. Become a student to the best of your ability of chemical grout. The more you know about it, the more you understand its technology that's controllable and that has its incredible value compared to other technologies. And I have tried hard to make this objective, but there's certain parts of me that says I'm less than objective because this is what I do every day. I wake up trying to figure out how I can get municipalities to take a more proactive approach in maintenance. I went to EPA One's website, and I saw where typically the things you wrestle with there are due to lack of maintenance. I think that's just so valid. But it's going to be difficult for all of us as a team, us as technologists and you as regulatory folks, how we're going to get people to take a more proactive role in maintenance so that we don't have to go to 3 to 4 times more expense with structural repair, and we can make these systems last for generations. And that's our obligation. I will be happy to get off my soapbox. I'm going to wish everybody a very wonderful day, and in return, I will share with Alex these promise documents, and I hope he shares that with you, and I trust he will. So we'll close for now, and until the next time, I wish you great weeks, and bye for now.
Thanks, everybody.